Figuring out how to do that is the value that the CSV module adds to your programs. You can apply lots of options both to the file in the call to open, and in the creation of the CSV.reader object. The example shows the minimal set. Note the reader object is not limited to file A. It can also take a list of strings as its input instead. This can be a powerful tool if you are using subprocess to generate CSV format data on Stout. Writing to a CSV file is just as easy. In this example, you create a new page of data for the toolhire.xlsx spreadsheet that lists the various tools available, along with some details about when they were made available, their condition, and original price. You save the data as a CSV file called tooldesk.csv that you can load into Excel as a new worksheet. Here is the code. Import CSV items equals 1. Lawnmower, small hover mower, Fred, $1. Handling common file formats 79. 44 As you can see, 1 lawnmower. Notice that the Scarify ER description once again has quotes around it, and the date fields are written exactly as is. If you want to get the dates in the same format as Excel produced in the original CSV file, you need to do that manipulation before you write the data. This is very typical of the kinds of inconsistencies you find when using CSV files as a transport between different applications. You can use the datetime module to convert the date formats. Datetime contains the datetime.stripTime function, which can parse an input string to a datetime object, and the datetime.stripTime function to write that datetime object out in the format you want. Try that out now. Try it out reformatting data and writing to a CSV file, change_date.py. In this try it out, you read a list of tools from the tooldesk.csv file, then extract each date filed from the list, convert the format of the date and, finally, write the entire data structure back to the CSV file. To do this, complete the following steps. 1. Change to the folder where you saved the CSV files, or create a new folder and copy the CSV files from the zip file. 2. Open your favorite IDE or editor. Type the following code and save it as change_date.py, or load it from the toolhire folder of the chapter2.zip download file. Import CSV from datetime. Import datetime. Def convert date, item the date equals item 1 date obj equals datetime.stripTime, the date, %y%m%d, date str equals datetime.stripTime, date obj, %m/%d/%y, item 1 equals date str return item. With open, tooldesk.csv, as td, rdr equals csv.reader, td, items equals list, rdr. Items equals convert date, item, for item in items. 80 Chapter 2 Scripting with Python. With open, tooldesk2.csv, w, new line equals, as td, wrt equals csv.writer, td, for item in items, wrt.writer item. 3 Run the script. Check that a new tooldesk2.csv file has been created. 4 Open the new file, tooldesk2.csv, in a text editor such as Notepad. 5 Confirm that it has the new date format, like this. 1 Lawnmower small hover mower Fred $150 excellent 01/05/2012 2 Lawnmower ride-on mower Mike $370 fair 04/01/2012 3 Bike BMX Bike Joe $200 good 03/22/2013 4 Drill heavy duty hammer Rob $100 good 10/28/2013 5 Scarifier, quality, stainless steel, and $200,09/14/2013 6 Sprinkler cheap but effective Fred $80,01/06/2014. How it works. You started off with the imports that you need, CSV and the datetime class from the datetime module. You then created a function to convert the dates. This starts by extracting the date filed from the record and then uses the datetime.stripTime function to parse the date filed. The format string, %y%m%d, tells it to select a 4-digit year, %y, followed by a hyphen, followed by a 2-digit month, %m, another hyphen, and a 2-digit day, %d. That produces a date object. You then use the datetime.stripTime function to format that date object in the required format by rearranging the fields and using / as a separator. Note that the datetime versions of stripTime and stripTime do not have the parameter order anomalies of the time module versions. Finally, you replaced the original date filed with the new string and returned the modified record. The main code of the script opens the original CSV file, reads the records, and stores them as a list called items. You then replaced items using a list comprehension that called your convert date function on each record in items. Finally, you wrote the modified items list out to a new CSV file called tooldesk2.csv. So far you have been using the basic reader and writer components of the CSV module that work with lists of data items. You may recall from earlier that CSV also supports a dictionary-based approach. You now use that to access the original toolhire.csv file. If you look again at the content of the CSV file, you notice that the first line is a list of headings that describe the columns. The CSV module can exploit that by using the headings as keys in a dictionary. This makes accessing individual fields much more reliable because you no longer need to rely on the numeric position of the field in the file. The way it works is very similar to the previous code, but instead of using a csv.reader object, you use a csv.dictReader. It looks like this. With open, toolhire.csv, as rdr equals csv.dictReader, Handling common file formats 81. For item in RDR, print, item. Date returned, 4/26/2012, description, small hover mower, owner, Fred, item ID, 1, date length, 4/1/2012, name, lawnmower, borrower, Joe, date returned, 1/5/2013, description, ride-on mower, owner, Mike, item ID, 2, date length, 9/5/2012, name, lawnmower, borrower, and date returned, 7/22/2013, description, BMX bike, owner, Joe, item ID, 3, date length, 7/3/2013, name, bike, borrower, Rob. Date returned, 11/29/2013, description, heavy-duty hammer, owner, Rob, item ID, 4, date length, 11/19/2013, name, drill, borrower, Fred, date returned, description, quality, stainless steel, owner, Ann, item ID, 5, date length, 12/5/2013, name, scarifier, borrower, Mike, date returned, description, cheap but effective, owner, Fred, item ID, 6, date length, name, sprinkler, borrower. Notice that, as is normal with a dictionary, the fields are not in the original order, and they are keyed using the labels from the first line. You can see that, as before, the scarifier description has lost the quotes but retained its comma. If, instead of printing the items, you store them in a variable, you can do some interesting analysis of the data using list comprehensions. For example, to see all of the items owned by Fred, you can do this. With open, toolhire.csv, as rdr equals csv.dictReader, items equals item for item in RDR, item name for item in items if item owner equals Fred lawnmower, sprinkler. You could do the same thing using the basic reader and its lists, but you'd need to use numeric indices, which are much less readable. For example, the list comprehension using the earlier list would look like this. Item 1 for item in tool list if item 3 equals Fred lawnmower, sprinkler. It isn't nearly so obvious what you are returning or what the selection criteria are. Also, if the file format ever changed, you would need to change the indices everywhere in your code. There is a matching dictWriter object that can write a dictionary out to a CSV file. You use it in the next try it out exercise. You can use the dictReader even if your CSV file contains no labels. For example, the tooldesk2.csv file that you created in the previous try it out had no label line. You can remedy 82 Chapter 2 scripting with Python that by reading it into a dictReader and then writing it out with a dictWriter. The trick is to provide the labels as an argument to the dictReader constructor. Try it out now. Try it out adding a label line to a CSV file, a dd_labels.py. In this try it out, you define a set of labels for the tooldesk2.csv file and then open the file and read it into a dictReader object. You then write the data out to a new file using a dictWriter that automatically inserts a label heading row. To do this, complete the following steps. 1. Change to your project folder and open your IDE or editor. 2. Type the following code and save it as a dd_labels.py, or load it from the zip file. Import CSV. Fields equals item ID, name, description, owner, price, condition, date registered. With open, tooldesk2.csv, as td_in, rdr equals csv.dictReader, td_in, field names equals fields, items equals item for item in RDR. With open, tooldesk3.csv, w, new line equals, as td_out, wrt equals csv.dictWriter, td_out, field names equals fields, wrt.write header, wrt.write rows, items. 3. Run the code and confirm that a new file, tooldesk3.csv, has been created. 4. Check that tooldesk3.csv has indeed acquired a header row by opening it in your text editor. It should look like this. Item ID, name, description, owner, price, condition, date, registered 1 lawnmower, small hover mower, Fred $150, excellent 01/05/2012, 2 lawnmower, ride-on mower, Mike $370, fair 04/01/2012, 3 bike, BMX bike, Joe $200, good 03/22/2013, 4 drill, heavy duty hammer. How it works. After importing CSV in the FiRST line, you define the file names as a list of strings. You then open the original file tooldesk2.csv, and read it into a list, items, using a dict reader that had been initialized with your fields list as its field names parameter. The next step was to write this out to a new file with a header line. To do that, you opened the new file tooldesk3.csv, and created a dict writer object specifying the desired order of the fields via the field name parameter. Remember that a dictionary stores the fields in an arbitrary order. You simply passed the same fields list that you used to read the file, thus maintaining the same order. You then called the write header method of the writer object and followed that by using the write rows method that writes out the entire items list in one go. Handling common file formats. 83. You've seen how to use the CSV reader and writer objects to convert between the CSV file format and Python lists, as well as the dict reader and dict writer objects to do the same with dictionaries. You've also seen 2 examples of modifying a CSV file format to make it more suitable for subsequent processing. The CSV module contains a few other features for dealing with non-Excel based CSV file, but you can read about those in the documentation if you need them. Working with config files. Config file, or, as they are often called, Windows INI file, have a very readable format that is also easy to work with programmatically. They have fallen out of favor in recent years because Microsoft now advocates the Windows registry and non-Microsoft applications are moving to XML-based storage. However, there are plenty of legacy applications around that use this format. A search for star.ini on a relatively clean installation of Windows 8.1 found several hundred file, so it is far from dead. The format is very good at storing multiple instances of similar data, such as per node settings on a network, or for multiple categories of options, such as various screen sizes, or online versus offline operational parameters. The disadvantage of the config format is that it can sometimes be too simple, with the result that complex data is harder to fit into the format. Python provides the config parser module for reading and writing config format data. Note the config parser module is one that has had a name change for Python version 3. In Python 2 it was known as config parser, capitalized, but in Python 3, it is now all lowercase, config parser. If you are working across Python versions, be aware of the name change. The functionality remains the same. The basic structure of a config file is as shown here. Default option 1 equals value 1. Section 1 option 2 equals value 2, option 3 equals value 3. Section 2 option 4 equals value 4, etc. The default section is noteworthy because options define there apply to all following sections. The format has a lot of flexibility, with spaces and indentation optional, embedded sections, and various other variants, including the ability to interpolate a value from one option into another. 84 Chapter 2 Scripting with Python. Option. The config parser module can handle all of these and much more. It converts the data into, or from, a dictionary format similar to the kind used for the CSV file described in the previous section. Basic usage is shown very clearly in the documentation with examples of creating a file and reading from it. Because there is little point in repeating that here, you can browse it at your leisure and then try it out in the following example. Try it out creating and reading a config file. In this try it out, you create a config file such as might be used for the tool lending application discussed earlier. This config file describes the standard settings and any user specify C overrides to those values. The settings are limited to the lending period, expressed in days, and the maximum value of items that can be borrowed. 0 implies no limit and is the default value. To create the file, complete the following steps. 1. Create a project directory and change into it. 2. Start the Python interpreter and type the following code. Import config parser as cp-conf equals cp config parser, conf default equals lending underscore period, 0, max underscore value, 0 conf Fred equals max underscore value, 200 hashtag Fred's a bit rough with things. Conf an equals lending underscore period, 30 hashtag she is a bit forgetful sometimes with open, toolhire.ini, w, as toolhire, conf write, toolhire, 3. Check that a new file toolhire.ini has been created in your folder. Default lending, Fred max under, and lending under, having created the 5 go back, del, handling conf to 6 see how it works. Having checked that the file existed and contained the correct after importing the module in the Fiverr line, you created a config parser object and then assigned a dictionary of name/value pairs to the default section. You then stipulated a limit on the value of what Fred could borrow. He has a track record of breaking things, as well as a limit on Anne's lending _period, because she tends to forget to return things, so she needs a reminder. You then opened the file, toolhire.ini, in write mode and used the config parser object to write the data to the file. Having checked that the file existed and contained the correct data, you then set about reading the data back from the file. In preparation for doing that, you deleted the original parser object and created a new one, reusing the name conf. You used conf to read the toolhire.ini file. You checked that the expected sections were available and saw that the default section was not included in the list. You then read some option values from the parser and saw that you could read the default values even though it was not listed as a section. Furthermore, the default values are used when a particular option is not explicitly declared for a user. For example, the default max_value is returned for Anne even though she only had lending _period specified. You then tried pushing the boundaries a bit to see how the parser handles error conditions. The Fiverr attempt was to access a user for which no values had been provided. This gave a typical dictionary key error. You then read the available options for Anne and discovered that the parser returned the default values as well as those explicitly defined. You also discovered that options does not work. 86 Chapter 2 Scripting with Python. For the default section, and you needed to use the explicit defaults method to fetch those options. The non-standard behavior for defaults is one of the few annoyances you will experience in using config parser. Working with XML and HTML file. You are probably familiar with HTML as the language of web pages. XML is also widely used as a so-called self-describing data format. XML and HTML are closely related formats. XML is a much more rigidly defined format, and that makes it easier to process using a computer. HTML is very forgiving of malformed content and, although that makes it easy to create by hand, as well as with specialized editors, HTML is much more hit or miss to process accurately. HTML also has many variations because of web browser proprietary extensions. All of this means that HTML parsers have a trickier job and often yield less than perfect results when faced with badly formatted files. Because XML is easier to handle programmatically, you look at parsing it Fiverr and then extend the technique to cover HTML. Note a form of HTML, known as XHTML, is also valid XML. XHTML is starting to appear on websites as increasing numbers of web publishing tools support it. This means that you can use XML parsers to parse XHTML as well as other forms of XML. However, HTML5 has, in effect, deprecated XHTML, so its use in the future is likely to diminish rather than increase. Parsing XML files. Many different parsers are available for parsing XML. The Python standard library contains no less than 5 EE, DOM, Minitum, XPath, Elementary, and Sax. These all fall into two categories, those that read the entire file into a tree-like data structure called a document object model, DOM, or those that read the file looking for items of interest, an event, and triggering a response as the items are found. The former are more flexible for complex, or multiple, queries on the same set of data. The latter tend to be faster and slightly simpler to use. In this book you only look at two of the parsers, each representing one of these two approaches. The Fiverr parser you consider as Sax, which is an example of an event-based parser. To understand how event-based parsers work, consider the following example that parses some plain text. Text equals, Mary had a little lamb, its fleece was white as snow, and everywhere that Mary went, the lamb was sure to go. Def has _Mary, a line, print, we found, a line. Handling common file formats 87. Def parse _text, the text, a pattern, function, for line in the text.split, \n. If a pattern in line, function, line, parse _text, text, Mary has _Mary, we found, Mary had a little lamb we found, and everywhere that Mary. Here you create some text that you want to parse. You then define any a function, has _Mary, that you want to be called every time Mary is found in the text. Next you create your event-driven parsing function, parse _text. This function iterates over the input text line by line. If the search string, in this case Mary, is found, then it calls the function that has been passed in. When you execute parse _text, with your text string and the has _Mary function as arguments, it prints out the two lines containing Mary. The Sax module works in a similar way to your parse _text function, however, it uses events, such as detecting the start of an XML element, rather than plain text patterns. It takes in an XML source text in a collection of events and associated event handler functions. It then processes the XML text section by section, and if it finds a match to a given event, it calls the associated handler to deal with it. The parser does not store the XML data, it simply iterates over it. If you need to go back to access earlier data, you need to reparse the entire file. To investigate the SAX parser, you need an XML file. You can find one, called toolhire.xml, in the toolhire data folder of the chapter2.zip file. This is simply an XML export of the toolhire.xlsx spreadsheet that you used earlier. A fragment of that file, including the parts you will be extracting, slightly edited for readability, is shown here. Item ID name description owner borrower date lent date returned 1. 88 Chapter 2 Scripting with Python. Lawnmower small hover mower Fred Joe 2012-00-0000.00.2000.2016T00:00.00.00. Assume you want to find the average length of loan. You use SAX to extract just the date lent and date returned fields for each item and store them as a tuple in a dates list. You can then later process those dates to find the duration for each lent item. To initialize the parser, you need to create your handler and specify the events that you are interested in. SAX actually uses a handler object, an instance of the xml.saxhandler.contentHandler class, or more specify Kali, a subclass of it, to combine the event and function. Several predefined handler subclasses exist, including one for dealing with errors. The advantage of this approach is that many default methods are already defined and others can be easily overridden, such as start document, called at the very beginning of parsing and useful for setting up state variables and the like. For simple XML parsing tasks, you normally create a custom subclass of content handler and then write your own versions of the start element, end element, and possibly the character methods. By inspecting the XML file, you can see that the data you want is contained in an element and is identified by the SS-type attribute being set to date time. The actual data is character data that sits between the start and end tags, so the expected event sequence is start element, followed by character, followed by end element. The code for your toolhire handler class looks like this, and is in the toolhire folder of chapter2.zip as toolhiresax.py. Import xml.sax import xml.sax handler. Class toolhire handler, xml.saxhandler.content def start element, handling common file form, else, set def characters, if underscore on, the initializer calls the superclass initializer and then sets up various data attributes that you use in the parsing and need to use across methods. It also creates an empty dates list to hold the results. The main parsing method is the start element, method that looks out for data elements and, when one is found, refines the search by selecting only those with a SS-type attribute of date time. You have to identify these values by inspecting the XML file manually. Because you can have up to 2 dates in a single row, you use the self.date counter to keep track of which date within the row you are handling. You use the self.isDate value to indicate to the character method that it is inside a date element. If the data is not a date time type, then you reset the self.date counter to 0. The end element method ensures the self.isDate flag is reset to false ready for the next start element event to come along. The character method is called whenever content outside a tag element is encountered. You are only interested in the date information, so if the self.isDate flag is not set, you simply ignore the character data. If the data is a date, then you check if it's the first date, in which case you store it in the self.datelent attribute. If it's the second date, you store both dates in the self.dates list. If only one date is found, the character handler is not called a second time, and the date is not added to the dates list, thus ensuring you store only pairs of dates, which is what you need for the duration calculations. Finally, the driver code at the bottom creates the handler and parser instances. It then sets the handler within the parser to your toolhire handler instance and executes the parse operation on your XML file. After parsing is complete, it prints out the collected dates from the handler. You repeat this exercise using the element tree DOM-based parser in the try it out at the end of this section. There you can compare and contrast the two techniques. First, though, you look at parsing HTML because the standard library HTML parser is very similar in style to the SAX XML parser. Parsing HTML files. The standard library provides the HTML.parser module for parsing HTML. It works in a similar way to the SAX parser, in that it is event-driven. It is slightly simpler to use because it only has a 90 Chapter 2 Scripting with Python single class with the handler methods defined within it. To show how it works, you once again extract the dates from the toolhire.xlsx spreadsheet, but this time from the HTML export. You can find this file in the zip file under the toolhire data/toolhire_files folder as sheet001.htm. The file looks, in part, like this. http://www.w3.org/tr/rec-html40. Item ID name description owner borrower date lent date returned 1 lawn mower small hover mower Fred Joe April 1st, 2012 April 26th, 2012. You can see that the dates have a unique class, namely XL65. This means you can look for tags with that class attribute value in a similar way that you did with the earlier XML example. The HTML parser class works very like the 6 content handler class in that it has methods corresponding to HTML document elements. In the example you override the handle_starting, handle_end tag, and handle_data, methods that are directly analogous to the start element, end element, and character methods for XML. Handling common file formats 91. You can find the code for this example in the zip file toolhire folder as toolhire.html.py. It looks like this. Import html.parser. Class toolhire parser, html.parser.html parser def__init__, self super, .__init__, self.dates equals self.datelent equals self.isDate equals false self.dateCounter equals 0. Def handle_starting, self, name, attributes if name equals td, for key, value in attributes, if key equals class and value equals XL65, self.isDate equals true self.dateCounter plus equals 1 break else, self.dateCounter equals 0. Def handle_end tag, self, name self.isDate equals false. Def handle_data, self, data if self.isDate, if self.dateCounter equals 1, self.datelent equals data else, self.dates.append, self.datelent, data. If __name __main__, htm equals open, sheet001.htm, .read, parser equals toolhire parser, parser.feed, htm, print, parser.dates. If you compare that with the SAX example, you see that the code inside the methods is nearly identical. The HTML parser presents its attributes as a list of tuples. You iterate over that list looking for a class attribute of value XL65 to identify a date filed. Note that's an XL not X1, remember that this is an export from Microsoft Excel, hence the class name. The parser conveniently takes care of mixed case HTML tags or by converting tag names to lowercase, so you don't need to worry about that. It also does its best to make sense of badly formed HTML, although it's not perfect and really bad code can trip it up. You conclude this section on reading data file with a look at another of Python's XML parsers. This time it's element tree, and you investigate it in the following try it out. Try it out parsing XML with element tree, toolhireet1.py and toolhireet.py. In this try it out, you use the element tree XML parser to extract the same set of dates that you did in the earlier examples. You also use the data to calculate the average loan period for the items in the spreadsheet. To get the answer, complete the following steps. 1. Create a new project folder and copy the toolhire.xml file, which you used earlier, into it. 92. Chapter 2 Scripting with Python. 2. Open your IDE or text editor and type in and save the following code as toolhireet.py, or grab toolhireet1.py from the zip file e. Import xml.atree.elementtree as et. Import datetime as dt. Def parse dates, file name dates equals rows equals dom equals et.parse, file name, root equals dom getroot, for node in dom iter, if row in node.tag, rows.append, node, for row in rows, row_dates equals for node in row.iter, for key value in node.attribute items, if type in key and date time in value, row_dates.append, node.text, if len, row_dates, equals 2, dates plus equals row_dates return dates. Def main, print, parse dates, toolhire.xml. If __name __main__, main. 3. Open an OS console window and navigate to your project folder. 4. Run the file from your console using Python 3 toolhireet.py, or toolhireet1.py if using the zip file. 5. Check that the output looks like this. 2012-04-01T00:00:00.00, 2012-04-26T00:00:00.000, 2012-09-05T00:00:00.00, 2013-01-05T00:00:00.000, 2013-07-03T00:00:00.000, 2013-22T00:00:00.000, 2013-11-19T00:00:00.000.000, 2013-29T00:00:00.000.000, 2013-12-05T00:00:00.000.000. 6. Go back into your IDE or editor and add a calculate average function and modify main, as shown, or load toolhighread.py from the zip file e. Def calculate average, dates loan underscore periods equals while dates, length equals dates.pop, 0, split, t, 0 ret equals dates.pop, 0, split, t, 0 length underscore date equals dt datetime.strip2me, length, %y%m%d, ret underscore date equals dt datetime.strip2me, ret, %y%m%d, loan underscore periods.append, ret underscore date, length underscore date, days, average equals sum, loan underscore periods, /len, loan underscore periods, return average. Accessing native APIs with types and PYWIN3293. Def main, dates equals parse dates, toolhire.xml, average equals calculate average, dates, print, average loan period is, days.format, average. 7. Save the file and run the code. You should see a message telling you that the average loan period is 44 days. How it works. You started by importing the element tree parser and assigning it an alias, et. You then imported the datetime module as dt in anticipation of the date calculations to follow. You created the parseDates function that starts off by parsing the XML file into a DOM. Notice that the parse function takes a file name as an argument, not a file object. You then obtained the root node from that DOM using the getRoot method. You used the iter method to find all nodes, as signified by the asterisk argument. You then inspected the node, and if it had row in its tag, you added the node to the rows list. Having built a list of rows, you then drilled into each row and examined the cells. You checked their attributes looking for a key of type with a value of date time. Once found, you inserted the date nodes into the row underscore dates list. At the end of each row, if the row underscore dates list contained 2 dates, you added it to the dates list, otherwise, you just ignored it. You returned the final dates list at the end of the function. You then tested the function and checked that the output was the expected list of dates. You next added the new function calculate average, and modified the main function accordingly. In the calculate average function, you initialized a list to hold the length of each loan. You then iterated over the dates list, extracting them in pairs. You knew the pairs matched because you only added pairs of dates in the parseDates function. The extraction process involved splitting the date strings on the letter T and only keeping the phi-rst part of the string. You had to split the strings because the datetime.strip2me method cannot handle the decimal seconds value. The next step was to convert the date strings into datetime objects using the strip2me method. You then used the datetime object's arithmetic capabilities to compute a time delta representing the loan period and stored the day's value in the loan underscore period list. Finally, you calculated the average of the stored periods and returned the result. Some applications do not lend themselves to generating data files. In these cases, you may need to interact with the program via an application programmer's interface, API. The next section shows you how. Accessing native APIs with types and PYWIN32. Some applications or OS functions are not easily accessed from regular Python code because no Python API exists or no user-friendly operations are exposed that you can call from Python. The types module can provide an alternative means of access by exposing to Python the C code libraries from which the application is built. In Windows, these libraries are typically a set of DLL. 94 Chapter 2 Scripting with Python. Another package, installed by default in the active state distribution of Python for Windows, or available for download on other distributions, is PYWIN32. This package provides access to the Windows native libraries and, in particular, to any Microsoft Component Object Model, COM, interfaces. Being Windows specify C, it is usually easier to use than types, which works generically on any operating system. The same caveats apply when using PYWIN32 as apply to types. Accessing the operating system libraries. One area that is usually well documented is the OS Application Programming Interface, API, that is exposed in standard system libraries. In this section you use the OS libraries to perform some fairly simple tasks that are nonetheless not available via Python's OS module. This method is particularly useful for Windows users because many of the Unix-like features in the OS module do not work, or only work partially, under Windows. Accessing the WIN32 API directly via types, or PYWIN32, is often the only option. File or, in Unix, a set of shared object libraries. Types enables you to load those libraries into your application and call their functions directly from Python. This only works, of course, if you know what functions are in the library, what arguments are required, and the return values. This may not be published, and you then have to resort to trial and error, or reverse engineering, which may, in turn, be prohibited by the manufacturer or vendor. However, if the library has a published interface, types provides an effective, although non-trivial, method of access. Some words of caution. Using types requires a basic knowledge of C programming. If you don't have that skill, you may want to skip this section because it may not make much sense. On the other hand, skimming it lets you see what the potential is, should you need it. When you use types, you leave the safety net of the Python interpreter behind. Remember that you are working with the raw OS libraries and sometimes directly accessing memory locations. The libraries also work with the raw file system and input/output streams, and so they may not show the results you expect in an IDE like idle or Python Win. If you make a mistake, you can easily cause the Python interpreter to crash. In extreme cases, you could even cause the OS to crash. This is why you should treat types and its friends as a last resort, only to be used when all else fails. Note types does not work with static libraries nor does it work with C++ libraries, unless the functions have been explicitly exported as C functions from the C++ code. The following sections show types being used on Windows and Linux systems, but the principles are identical, apart from getting the initial reference to the C library. Accessing native APIs with types and PYWIN3295. Using types with Windows. On Windows systems the basic C library is found in the MSVCRT library. Some functions in MSVCRT.dll, mainly concerned with console input/output operations, are exposed in the Python MSVCRT module, but many more are not available by that route. You can easily access the native MSVCRT library from types using the following code. Import types as ctlib equals ctcdll.msvcrt #Windows only. Once you have a reference to the standard library, you can call the familiar C functions. The only implication is that you need to ensure the arguments are type compatible with C. In general, integer arguments work just fine, but strings usually need to be explicitly marked as byte strings, and floats need a special type conversion. Many type conversion functions are included in types. You can find a full list in the module documentation. Here are two examples. lib.printf, b, %d%s hanging on a wall \n, 6, b green, b bottles, 6 green bottles hanging on a wall 34 lib.printf, b, pi is, %f\n, ctc_double, 3.14159, pi is, 3.14159.016. Notice the use of b to indicate a byte string and, in the second example, the use of the types.c_double, conversion function. Also, note that the return value of printf, which is the number of characters printed, is displayed after the message is printed. Many C functions require pointers to data, effectively memory addresses, as arguments. Types enables you to do this using the byref function. You can create an object of a given type and then pass that object using byref into the types function call you want to perform. Here is an example of using scanf, that reads an integer value from a string into a Python variable. d equals ctc_int, print, d.value, 0 lib.scanf, b6, b%d, ct byref, d, 1 print, d.value, 6. Next you look at a slightly more practical function in the Windows library, MSVCRT. _get drives. This returns a list of available drives on a Windows system, something not easily done using Python's standard OS module. The only complication is that the returned list is a bitmask, so you need to write a loop to test each bit to find out which bits are set and map the bit position into a drive letter. Here is the code. Drives equals abdifgijklnopkrstavuxies drive list equals lib_get drives. 96 Chapter 2 Scripting with Python. For n in range, 26, mask equals 1. The Microsoft Developers Network, msdn.microsoft.com, has full documentation for the standard Windows library functions. Using types on Linux. You can use types on non-Windows systems, too. Here is an example using printf, on a Linux system accessed via the standard C library lib.so.6. You can also use other Unix-like OSs if you can find out the name of the library that implements the standard C library functions. Import types as ctlib equals ctcdll, lib.so.6, lib.printf, b, my name is %s\n, b Fred, my name is Fred16. The printf and scanf examples in the previous section should also work using the Linux lib, as will the byref function and the various type conversion functions. Accessing a Windows application using COM. Accessing an application library is almost as easy as accessing an OS system library, provided you can get documentation for the contents of the library. However, that is not always readily available. Another option on Windows is to use the OS functions to access the COM objects and then manipulate the COM objects from Python. Unfortunately, COM is a complex technology and has been extended over time to include features such as distribution over a network as well as various data access mechanisms. Compounding the difficulty is the fact that documentation for COM objects is often sparse and hard to find. Nonetheless, COM is often the most effective option for automating Windows applications. The easiest way to use COM objects in Python is to use the pywin32 package, written by Mark Hammond and available for download from the SourceForge website or included as standard in the active state distribution of Python. The following try it out demonstrates the use of pywin32 to open Excel preloaded with the tool hire.xlsx file you used in the earlier sections of this chapter. Try it out using COM to present a file open dialog, tool hire com.py. This try it out demonstrates how to use the Excel COM interface to open the application and let the user select a file all from within Python. If you are using Windows, follow along with these steps. This example works under Windows only. 1. If you do not have the active state version of Python installed, download and install the pywin32 extension package from the SourceForge website, http://sourceforge.net/projects/pywin32/http://sourceforge.net/projects/pywin32/. Accessing native APIs with types and pywin3297. 2. Open your Python IDE and create a new file called toolhirecom.py, or load it from the zip file. Enter the following code, making sure to set the file path to your own file location. Import win32com.client as com #, set the file path as required on your PC. File path equals rd/python code /chapter2 /csvexamples /toolhire.xlsx, file open equals 1 # found by trial and error. App equals com dispatch, excel.application, app visible equals true, fd equals app file dialog, file open, fd.initial file name equals file path, fd.title equals open the tool hire spreadsheet, if fd.show equals -1, fd.execute. 3. Save and run the file. 4. Click OK in the dialog box that opens. 5. Confirm that the spreadsheet contains the data from the spreadsheet you used earlier. How it works. After importing the win32com.client module and aliasing it as com, you set the file path to a variable so it's easy to change if needed. Note, you should use the path to your own folder, not the one that is used here. The next line sets a file mode variable to 1. This determines what kind of file dialog is opened, in this case a file open dialog. The value was found by trial and error, valid values lie between 1 and 4. You then created the application COM object using the dispatch function and made the window visible by setting its visible property to true. At this point the window appeared on screen but without the usual grid of cells. This is because Excel actually stores the grid in another COM object called a workbook. You could have created a workbook, or more accurately a set of workbooks, or tabs, and opened the file directly instead of using a dialog box if you knew which file you were interested in. Workbook objects contain cells, and it is these you would use if you wanted to create or modify data within a spreadsheet. The next step was to create the dialog object using the file dialog method of the application. This took your file mode value as an argument. You then set a couple of attributes of the object to ensure it opened in the right place and with an instructive title. Finally, you called the show method of the dialog that displays the dialog box on screen, with all the usual functionality available to the user. If the user selects the OK button, the return value is 1. In this case you can call the execute method of the dialog object that proceeds to open, or save, if necessary, the selected file. At this point the spreadsheet gets populated with the workbooks and appears as you would normally see the application. You have now seen many techniques for integrating different applications in a scripting program. The next section gives you some advice on how to bring these techniques together to complete a scripting project. 98 Chapter 2 Scripting with Python. Automating tasks involving multiple applications. Scripting was defined at the start of this chapter as